Did you know you can differentiate almost any function in your A-level math syllabus using this principle? To give an example, let's prove that the derivative of sine x is equal to the cosine of x. For this example, we're going to have to imagine the function f of x being sine of x, in which case we can rewrite the equation like this. First of all, we want to try and get cosine of x in the numerator, so let's use the angle addition formula for sine and expand sine of x plus h. Now that we have everything we need, let's try to simplify this equation a little bit by factorizing out sine of x. And now comes the tricky part, which is applying the limit. When you apply the limit as h approaches 0 to an equation, you are basically trying to see what happens to that equation when h gets closer and closer to 0. So now in order to apply the same principle to our original equation, let's separate terms so that it's easier to see where the variable h appears. Now we have two expressions in terms of h that we can apply the limit to. In the first equation, if we plug in decreasing values of h in our calculator, we notice that the value of the cosine of h minus 1 divided by h will approach 0. In the second equation, if we plug in decreasing values in our calculator, we can see that the value of sine of h divided by h approaches 1. Therefore, we can replace both of these expressions with their limit in the original equation.